Hello everyone. In this lesson we will look at applications and limitations of transformers. So let's see some of the key applications. So first application is in NLP domain where we can use it for machine translation, summarization, sentiment analysis and many more. Then next it can also be used in vision and we will see this vision transformers sometimes later in the course, and it can be used for image classification. It can also be used in multimodal tasks like text to image, text to video, and some other categories. And then apart from these major key applications, we also have some other applications like in scientific applications like protein folding predictions as in AlphaFold. So now let's see some more examples. So there is something called zero shot learning. So we have some models which are trained for some general tasks, but we can guide the model to perform some specific task which it was not trained on. For example, we can ask the model to predict a sentiment of a review, although it was not trained for sentiment analysis. So we know that if we give enough data, this model has good understanding of the language and its constructs. So it's able to distinguish, like if we have written some review like this movie is really fantastic. So it understands as we do in similar fashion that it's something positive. So we can specify our requirement to the model through prompt, like we want to know whether this is a positive sentiment or negative sentiment, and just output 0 for negative sentiment, 1 for positive sentiment. So we can guide the model and then accordingly it can generate that, although we hadn't trained it specifically for sentiment analysis. In the past, like we used to train, if we want to do sentiment analysis, we could train a model to do so. So it could be a binary classifier or some 3-class classifier, or it can predict rating from 1 to 5. But let's see an example. So we have a model called this BART large MNLI, and it was not trained for categorizing the movie into its genres. So we have given it a text which describes a movie, like the new movie was thrilling adventure with amazing special effects, and we want the model to predict what was the genre, whether it was action, comedy, drama, sci-fi or horror. So we load a zero shot classification pipeline, and this is the model path. And so we specify the candidate labels, one of these 5 candidate labels, and then we ask the classifier, which is this model, to assign predict scores to all of these. So it has given a prediction that this first one has highest probability 0.63, next 0.29, and so on. Others are very small. So the model thinks that it's most likely an action movie. And you can see that it seems like an action movie, special effects, adventure, thrilling, and some low probability with comedy also, but majorly action. So using this, we can write our own programs, and we can use this model for predicting the genre of movie. We can think of hundreds of such applications, classification tasks, using this kind of approach where we give the class labels. In some other use case, we can ask it to predict positive or negative, and we will give just 2 labels, positive and negative, and it will assign some probability. So this is called zero shot classification. Next comes few shot learning. So it learns from a few limited number of examples, typically 1 to 5. In the zero shot, we had given 0 examples. We had just given commands, no examples. Here, it may not do that well without giving any example. So we will need to provide some examples. Like this is an example. I am translating this task to French. So I am giving you an input where I write an English text and then an arrow and then its French translation. Similarly, in second example, again another text and another translation. Now I give you third text and an arrow, and your task is to write the translation here. So we had given some examples, and the model will has learned some a pattern from this example, and then based on that it will try to give the translated tasks. So it's useful when the level data is scarce or expensive to obtain. So we can use a generalized model which is good in some NLP task, some general NLP task, and we can guide it to do our job. So let's see an example. So this time we use text to text generation model, and we use Flan T5 Excel. So I have written a review like this is the worst experience I ever had. And we want this model. This is not a classification model. It's not a classifier, it's a text to text generation. We give some text, it gives some text back. So we ask it in the prompt itself, you will see that we are giving some examples. So we say that classify the sentiment of the following sentences as positive or negative. We want either positive or negative. And we give some examples, like if input is this movie was absolutely fantastic, you should output positive. The food was terrible, then the output should be negative. I had a pretty average day, it's neutral. Although we have not given here neutral, but yeah, you get the idea. And then finally we give the query here. So whatever is the query, you can write query here also, but from a program point of view, if let's say your function takes a query and it outputs a sentiment, so you can feed the query here and then you leave the output blank. Now if you check the response from this LLM, you see that response is negative. So it understands that this is a worst experience I ever had is negative based on the pattern it learned, like in what format I should output it, and based on its understanding it outputs negative. So you got an idea. Now let's see some limitations of transformers. So by this time you must have known that the computational costs to these transformer models is really high. It needs high training and inference costs. For example, GPT-3 requires significant GPU, TPU resources. So in order to fix these, we can go with these large models only if it's required absolutely for our use case. If not, we can try with some more efficient architectures and lightweight models like DistillWord, MobileWord, etc. So if these models can achieve your task, then better try with smaller models. And then these models are very data hungry and it requires massive data sets for training. So it's not always recommended to train these large models from scratch, but you can use some pre-trained models and that will reduce the data requirement. That fine-tuning part, it can be done with much smaller data. So this you can fix using that. Then we have some difficulty in understanding how predictions are made. So for that you can develop techniques to understand model decision. And then there are some ethical concerns where potential for bias and misuse is happening. For example, deepfakes, where the person in the video or image is replaced by some other person. So it can have some misuse also, and then depending on how it was trained, it can have some inherent bias in the model itself. So for that we can develop frameworks for responsible AI uses. And now in the next lessons we will focus our attention on pre-training, fine-tuning, and we will look some applications of transformers beyond text.